Welcome back to the deep dive. Today we're going to be pulling back the curtain a bit.
Or the drywall, maybe.
Yeah, the drywall. We're looking at the kind of invisible tech that makes high-end AV setups work. Specifically, the datasheet for the Kramer UHD-OUT4-F32.
It's quite a name.
It is.
But it's a really critical piece of kit. It's a 4-channel HDMI output card.
Right. But let's be super clear here. This is not something you just go buy for your home theater setup.
Oh, definitely not.
This is a modular card. It slides into this massive chassis, the VS32322DNEM modular matrix switcher.
You can think of the big switcher as, I don't know, a highway interchange for video signals.
Okay.
And this little card is basically 4 of the main exit ramps. It's what gets the video out to the actual screens.
An expensive exit ramp, though. The card itself is around, what, $1,084?
Yeah.
For one component?
Yep, that's the price.
So that's my mission for this deep dive.
Right.
Why? What really separates a $1,000 output card from, a $10 HDMI splitter you can get online?
It really boils down to 2 things: bandwidth management and, I'd say, signal survival.
Okay, let's start with bandwidth. The specs say it handles 8.91 gigabits per second.
Per second, yeah. And that gets split, so you're looking at about 2.97 GBPs for each channel.
And that's what gets you to 4K at 60 hertz.
It is, but there's a little asterisk there if you look closely in the datasheet. It supports 4K 60, but at 4.2.0 color subsampling.
Ah, which is, technically speaking, a form of compression, right? You're actually losing some color information. Why would that be acceptable in a professional environment?
Because our eyes are just way more sensitive to changes in brightness, that's the luma, than they are to color, the chroma.
So you can cut down on the color data without anyone really noticing.
Exactly. You save a huge amount of bandwidth, which lets you hit that smooth 60 frames per second without completely choking the system. It's a very clever trade-off.
Okay, that makes sense. So that's efficiency. But what about what you called signal survival? The datasheet makes a big deal about Kramer equalization and reclocking technology. And yes, they spell clocking with a K.
Of course they do. But marketing aside, the technology is very real. When you send a high-frequency digital signal down a long copper cable, it degrades.
It gets messy.
Very. What starts as a perfect square wave gets rounded off and distorted. We call that jitter. The display on the other end might not even be able to read it properly.
So this card doesn't just amplify the signal.
No, it completely rebuilds it. That reclocking process strips out the jitter and generates a new, perfectly timed signal. That's how it can push 4K for 10 meters or even 1080p for 15 meters without any artifacts.
That's pretty far for standard copper. And that's just the video. It also handles, what, 7.1 channel audio?
Yeah.
Dolby, True HD, DTS HD.
And it does all of that while maintaining HDCP 1.4 compliance. That's the copy protection handshake. If that fails, the screen just goes black.
Which brings me to the feature I actually found most interesting, the EDID capture.
Ah, the unsung hero.
Explain that. What is EDID?
EDID is basically the data a monitor sends out that says, hey, I'm a Sony display and this is the resolution I can handle. The problem is, if you unplug that monitor, the source device panics and might default to a low resolution.
A total nightmare if you're in the middle of a live event.
A total disaster. So this card captures and stores that monitor ID. It basically pretends the monitor is still connected, even if it's off or unplugged. The source is happy, and when you switch back, it's instant, no flicker.
Now, I have to bring up the durability specs, because I honestly thought they were typos.
You know the ones you mean.
Operating temperature is -40 to +70 degrees Celsius. That's up to 158 Fahrenheit.
That's not consumer grade, that's industrial, even military grade territory.
You could run this thing in a commercial freezer or, I don't know, a server rack in the desert.
And that's exactly where they end up. Places like stadium control rooms or on ships where conditions are extreme. And it does all that on just 8 watts of power.
So, to circle back to my first question, you're paying that $1,000 not really for a better picture, but for the absolute guarantee that a picture will show up.
Precisely. In a command center or a huge video wall at a trade show, the technology needs to be invisible. You're paying for reliability. You're paying to ensure that signal survives its journey from the rack to the wall perfectly.
It's all the heavy lifting you never get to see.
And that's always the most expensive kind.
Something to think about next time you see one of those giant, flawless video walls. It isn't magic, it's just some really, really good reclocking. Thanks for listening to this deep dive.